Well, I thought I was going to film some more of this, but I've just been plodding up here a bit of time getting it done. So anyway, previous video was that mess of wiring on the bench, the 6P15P based valve amplifier. Well, here is the finished article. So doubler based PSU, that's the voltage doubler down there. So you can see it's using the transformer secondaries are in series, giving me 110 volts AC. There's the two diodes coming off one winding, one end of the winding, one's sent to go to the positive of this capacitor, one's sent to go to the negative. The other winding goes where these two tie together. That's a voltage doubler. Then the positive comes off one end, negative off the other. Multi-stage RC filtering. That's main HT for the goes to power the output transformers. Another stage of filtering that goes off to grid 2, the screen grid on the output valves, and then third stage of filtering, which is what feeds the anodes of the input valve. Single-ended Pentode design, so output transformers, speaker terminals, bit of negative feedback. Here's the tag strip, the whole amp. So that is literally the entire amp is built on that tag strip, apart from a few grid resistors which go straight to the valve sockets. Yeah, and the circuit is that times 2 basically. So it's not bothered putting the power supply on here, but you can see it comes in 10k resistor to a 6M1P, 22k to 0V, that's the input. Cathode bias on the input stage, 2k2 to the cathode, another 2k2 actually goes through the output transformer. And one end of the output transformer does actually, I've not drawn it on the schematic here, but one end does go to 0V, the opposite end. So the cathodes actually have 1k1 in them because it draws current through both of them. 1 nanofarad stability cap across this resistor. Now that confuses a lot of people because it looks like you're applying more negative feedback as frequency rises. So you'd think, well, it's going to oscillate more. That's not that simple. It serves two purposes. It corrects for a phase shift which is happening in the output transformer due to it being inductive and pulls it back the other way. You need phase shift, not just feedback. You could apply enough feedback to have a gain of 1 if the phase never shifted enough for it to actually oscillate. But it also, at higher frequencies, the output transformer has its own resonant parasitic oscillation frequency thing it wants to do, and that helps damp that. And I would show you, but I've not got the test gear set up. If you put a square wave to it, it's really messy, wobbly one until you connect the 1 nanofarad cap up, and then it's nice and smooth with a slight dip off the edge, which means there's slight high frequency limiting, which is perfect. So yeah, 100k in the anode, so you can say this is some more RC smoothing. So 100 nanofarad cap. Yeah, I can't remember, I think that's actually about, I went with a slightly different value. It was whatever it was at hand at the time. It might be quite a bit higher, might be a bit lower. I think it might be 680 ohms I've gone with, but close enough. So the 470 and 330 ohm come to like 190 ohms. It just splits the load between two lower power resistors, allows them to be smaller on the tag strip, less heat. 25 volt, 100 microfarad bypass cap. I don't think I've gone anywhere near that. I think that's actually 680 ohms as well, or no, 820, I can't remember, something like that. Anyway, that's the these are 820 at 820 ohms I've gone with in the end on that one. Screen 2, it just helps damp the output valve from oscillating. I've had it before, output valves, if you don't add some level of resistance in screen 2 grid when you're doing point-to-point wiring like this one is, you can end up with it trying to oscillate at very high frequency, so it just damps that out. Yeah, that's just feeds the output transformer single end, which goes to the main HT. As the speaker sits across the output transformer, the feedback is applied via this. Dead simple amp. Works a treat. So yeah, it's using, this was just a 100 volt line amp, so you can see it used to have like some mic inputs and stuff, so I've moved the volume control over here because it keeps it away from the main side. I was going to wire these up so I could plug a jack into them and measure cathode current, but I just can't be bothered. So yeah, it's the feedback caps, various anode low resistors and stuff. That's the input valve, that's the two outputs. I can't turn it over in a minute because it's semi screwed inwards on itself. You can see under it, look, there's the valves. Yeah, all works, all fine. So yeah, if you want to build this amp, I can see it's a very stable amplifier. These, you could probably use some better transformers than these, but bear in mind that the values for the feedback network and capacitor are for these transformers. If you use better transformers, you'd probably want a smaller cap there, or maybe even no cap at all, or you might have to come up with a different scheme. That's the joy of especially things like valve amps with certain components. You have to design the amp to the components you're using. It's just a standard 6.3 volt. It's also an RS components part. 504561 is the transformer. Dual 6.3 volt 20 VA, which is more than enough at AC for these. And even this is an RS components part. This is the, if it'll focus, what's that, 6718971, a dual 55 volt transformer, and like I say, wired in series to give me 110 volts, and then put through a voltage doubler. Gives about 350 unloaded, loaded up about 317, perfect. So yeah, as always, thanks for watching, and catch you again.